All right, ladies and gentlemen, we are currently on page 75 of your booklet. I'm going to look at questions 17 and 18 together in one video. All right, now, the lead into this says, okay, we wish to do two things, one right after the other in succession, and sometimes the probability of the second event will be impacted by the first event. That's called a dependent event, and sometimes it will not, and that's called independent. And I think what they're trying to say up here makes a lot more sense after we actually work the problem. You'll see what's happening. So we want to draw a card and then replace it in the deck and draw a second card. What's the probability of getting a heart on the first card and a heart on the second card? Okay, so we have two things we're doing. Let's get a heart on the first card, get a heart on the second card, and then multiply these together to get the answer. So, what's the probability of getting a heart on the first card? Well, there are 13 hearts in the deck, and there are 52 cards in the deck. So the chance of drawing a heart on the first card is 13 out of 52. Now, we've drawn that card, right? We have it in our hand, but we're told to replace it, put it back in the deck. So now, what's the probability of drawing a heart on the second card? Well, on the second card, we still have 52 cards, right? Because we put this one back, and there's still a 13 out of 52 probability of getting a heart. I believe that reduces to 1/4. This reduces to 1/4. And remember, when you're multiplying fractions, you cross-cancel when you can, but there's no cross-canceling here that's going to help. 1 times 1 is 1. 4 times 4 is 16. So the probability of this event, this joint event happening, would be 1/16. Now, we're doing the problem again, but this time we do not replace the card. So I'm doing two things. I'm pulling a card. I'm pulling one card, and then I'm pulling a second card. Okay, excuse me. What's the probability of getting a heart? Well, 13 out of 52, okay? But this time we do not replace it, all right? We do not replace that card. So what that means is, when I'm trying to figure out the probability of pulling a heart on the second card, first of all, our deck only has 51 cards in it. Now, you with me? Because we kept the card from the first draw. We did not replace it. Therefore, there's only 51 in the sample space to pull from. And also, normally we would say there are 13 hearts to choose from, but there's not. One's gone. So this would become 12 out of 51. So look what I have. The first fraction reduces to 1/4. And then I have 12 over 51. And let's see what I can do there. That 4 goes into that 3 times. I have 3 over 51. And let me see my handy dandy calculator. What's 51 divided by 3? Aha. What I did is I took this 51 and divided it by this 3 to see how many times it went in. 3 goes into itself once, and 3 goes into this 17 times. Okay, so the biggest, not issue, but the biggest thing on this problem to remember is when you're doing two things, two events, event 1 and then right behind it, event 2, sometimes the second event is impacted by the first event. That's called dependent. They're dependent on each other. And other times it's not. That's called independent. For you, what you really need to remember is not these terms so much as with replacement, without replacement. And look what happened when we said we did not replace that first card. We lost one card on the bottom and we lost one heart on the top. Okay. And when you're working with fractions, remember the best way to cross cancel is to go gazinta, right? The gazinta rule. 4 goes into 12 3 times. 3 goes into 51 17 times, leaving you with the 1 on the top. Never leave home without the gazinta rule. Oh, let's take a peek out. Oh, yeah. And tonight we're supposed to have that beautiful pink moon. This is an awesome place to film from. There's my doggy, Teddy. Teddy, can you say hi to the people at home? Teddy. Okay, I've talked to him too much today.